Hello, this is Dr. Scott Denstead, founder of EZWxBrief, your best online source for aviation weather and education. Welcome to episode 28 of EZWxChat, a program to discuss various topics related to aviation weather. Well, welcome back everybody, and this particular episode is going to be a little bit different. I'm not going to talk about the EZWxBrief application. For the most part, we're going to look at a severe weather event that I'm sure most of you know about that occurred December 10th and 11th in the kind of middle Mississippi Valley area. And it's nothing that's specific to aviation weather necessarily, but it certainly has some elements to it that we can learn from. And first and foremost, this is not going to be an exhaustive analysis of that event. For the most part, I'm not going to pretend that I have looked at this in any great detail, so there may be a lot of errors and omissions in what I'm about to say. But I'm hoping that you can pick up a few elements here to understand better how an event like this can happen. So I'm showing this particular diagram here shows the various different severe weather events that occurred from 12Z on the 10th to 12Z on the 11th. So that basically covers most of the time period that this weather system impacted. Now, the fact that this happened in December is kind of unusual. And you may have heard about that on the news. This is not something we generally see in December. There have been some pretty significant weather events in December in terms of tornadic thunderstorms and major outbreaks and even major amounts of folks dying in this severe weather event. But it generally doesn't happen on a regular basis. So, why does something like this happen in December? And in many cases, is this kind of related to global warming that's going on right now? And I'm not going to focus a lot on the climate aspect of this. You can spend some time reading about that online. There's probably plenty of places out there that will talk a little bit more about this. But we do know that the atmosphere, through the fact that we are seeing a warming planet, mainly to increased greenhouse gases, and the fact that when you raise the temperature of the air up higher, more water vapor can be essentially evaporated into that air, and that the water vapor can eventually be condensed, and when condensation occurs, you get a release of latent heat. So it kind of feeds itself. And it doesn't take much when we're talking about global warming. Even a half a degree can be pretty significant overall. And a lot of this depends on the ocean sea surface temperatures that occur in the Pacific. You may have heard of El Nino and La Nina. These are what they call southern oscillations that will occur with the temperatures of the waters in the Pacific, and ultimately will impact what kind of weather we see here in North America. So in many cases, any specific weather event doesn't necessarily point to the whole global warming thing. But the fact that when we see more and more of these, and they're more significant over time, is a good indicator that some of these weather systems are energized by the higher, warmer temperatures that are occurring. So that's about all I'll say about the global warming aspect of things. In this particular situation, we're going to walk through a couple different charts, and I'm going to try to explain those a little bit, and then we'll talk about the weather setup that occurred. But again, I'm not going to be able to hit this in a lot of depth just due to the amount of time, and there will likely be many doctoral dissertations that will be describing this particular event, or this event will be part of those dissertations. So this is something that I know that meteorologists all around the country, if not the world, will be kind of feeding on in terms of understanding what went on here. But this basically shows you that there were some hail events, some wind events, and tornado events. And that's the way we define severe weather. Severe weather is not defined by how much precipitation or the amount of lightning that occurs. It's basically describing what's happening here in terms of the severe aspects of that. So there were 23 hail reports of less than 2 inches of hail in diameter, and there was one that was greater than 2 inches. The real aspect of this is really more of the wind, including 64 tornadoes. Again, as of 12Z, this number may go up as more and more storm reports come in and are verified, but 64. And then there are 362 wind events of 50 knots or greater, and 7 of those were 65 knots or greater. So this again gives us a really good indication of just the overall aspect of this. And kind of this is kind of overlaid over the Storm Prediction Center's Convective Outlook, the Day 1 Convective Outlook, and we'll pull those in. I think the thing that kind of surprises me is less that happened in December, but more that how people in general don't necessarily always prepare for something that occurs in December. You know, we're used to seeing these things in March, April, May, and even into the summer where we see some severe cases, even September and October. When we start thinking about major events happening in December, it's usually related to a nor'easter or a snowstorm. So most people in this area where it's showing the possibility of severe weather are not really mentally prepared for this. So they're not paying a lot of attention to the possibility of weather. And I think, and I'll probably be chastised by my meteorology buddies out there, my other friends that are in this field, but I think this particular forecast was not as good as it could have been. But again, that goes back to the fact that there's going to be a lot of people looking at this. Why that was not the case? I think it was a little bit underwarned, although, as you'll see, that there is a pretty significant signature out there for the fact that this was going to be a really major event in terms of its impact. I'm not suggesting that at all. Just a question of this probably should have had a higher level of interest in the media, and certainly the National Weather Service knew that something major was going to happen, but the actual indication that this was going to be as bad as it was really didn't happen until almost as the event was unfolding. And there's a lot of complexity to that I'm not going to be able to cover. So if we look at the Storm Prediction Center's forecasts here, and I'm going to kind of bounce around here, and I'm going to try to pull out a few things here. So let me do that. I've got a lot of these saved in a directory, and I'll pull those out as we talk through them. But if we look at let me just first of all start with the Easy Weather Brief so we can kind of look at the product in itself and what it provides you with these different forecasts. But let's go to the Storm Prediction Center's forecast, which I pull all together here. And what you'll notice is that the Storm Prediction Center produces a Day 1 Convective Outlook. They produce a Day 2 Convective Outlook and a Day 3, as well as a Day 4 to 8 Convective Outlook. So if we look at those in Easy Weather Brief, Day 1 is today, Day 2 is tomorrow, and Day 3 is the following day, and of course Day 4 through 8. So this is the way the Storm Prediction Center kind of looks at and says, we have a forecast here for thunderstorms or for convection, and this is how it's going to unfold from a standpoint of severe weather. So they're really mostly interested in severe weather, severe thunderstorms, tornadic thunderstorms. They also do forecast severe winter events like blizzards and freezing, significant freezing rain events, and they also do forecast fire weather. But from a convective standpoint, you have the day 1, day 2, day 3 forecast. Now, the hope is that even out at day 3, you're starting to get a really good sense of what's going to happen in a particular area. And in most cases, you can gain a pretty good understanding that this is going to be a significant event. So if we go back and look at the convective outlooks that were issued, we'll do the day 3 outlook first. So this would be looking at several days out. So let's go and look at that. So this is the day 3 convective outlook, valid basically all day on Friday into early Saturday morning, so basically covering most of the actual event. And for sure, this shows that there is a slight risk of severe thunderstorms. That would be thunderstorms that produce large hail, strong gusty winds, and possibility of tornadoes. And this is basically a categorical forecast. So the green area here is just general thunderstorm, not necessarily severe, and you'll have a higher risk of marginal, slight, enhanced, moderate, and high. You'll never see a high on the day 3 or day 2. Only on the day 1 will they put a high threat out there. The worst you can see is a moderate on the day 2 or day 3. But this, at least at a minimum, was showing a slight risk, an elevated risk of severe weather in that region. And it was pretty much right on the money overall. There was some more interesting weather up a little bit further north, but the main area that they're concerned about was pretty close to being accurate even out at this time. And if we look at the next day, so this would be like a couple of days out, if we look at the day 2 outlook to see what's happening from that standpoint, this will give us a better indication of kind of where this was heading. So if we look at this here, what we'll see is that they increase the risk. So the very next day they take a look at the same situation, and basically this was the day before the event. They look at this and they said, okay, now we're starting to see elements here coming together that will increase the risk in this area, so it's enhanced. Likely they should have had a moderate at this point in time, but when you read the discussions, you'll start to see that there's a lot of uncertainty in this pattern. And meteorologists have the same issues here. They try to be very unbiased by even what the calendar says, but ultimately you have to still have some part of you that says, well, this is a December event. How likely are we to see this kind of outbreak? And again, I think it really surprised a lot of meteorologists to be this severe. And there were at least, I think over 70 some lives lost, and that number could go up even more as they search through a lot of the rubble. So when we're looking at that, when we look at the day 1 convective outlook in the morning time frame, what we'll see here is that this is the day 1 outlook. So this is issued actually, the day 2 and day 3 are issued, they issue them a couple of times throughout the day, whereas this one they issue 4 times a day. There's one that's issued actually at, I think, 6Z, and that's valid at 12Z to 12Z the following day. Then at 13Z they refresh it, and that's what we're seeing here. And then they issue one at 1630Z and 20Z, and then again at 0Z, so ultimately, or 01Z. So ultimately this is updated, the day 1 is updated multiple times. So this is what it looked like in the early morning. Pretty much the same as what we saw in the day 2 outlook. But by the afternoon time frame, when they're looking more and more, trying to understand how is this all going to play out, eventually you'll start to see that the next one after that is, well, this is the actual, we'll get to this in a second here. Let me grab the other one. Here it is. Yes, there it is. So this is the day one outlook that was issued at 1630Z. So now the forecasters are looking a little more carefully. The models are starting to come into a little bit more of an alignment, and as a result what you end up with is a clear indication that this is a much more significant event where they add now a moderate risk. And likely this probably could have been or should have been even a high risk at this point, but that was not put out there. Now and again, I'm not going to suggest that that I could have done a better job at this. By no means, hindsight is 20/20, but that's what we learn when we go through these things. We learn from these kinds of situations. So now we can specifically kind of work through what is the severe element that we're concerned about. And so you can look at, for instance, this one shows you hail. So this says that you've got a 15% increase risk of hail in this area, large hail. It's basically hail that's an inch or larger in diameter. Then you can also look at the potential for wind as well. So this is the wind element here. So a 30% increase in probability for hail, and again that's looking at 50 knots or greater. And then you can also look at the tornado specific here, and you can see something special here is that that 10% area is essentially it's striped or it's hatched. And you may say 10%, it's not a lot, that's pretty small, but this is actually something I know that most pilots don't really understand, much less the general public. When they see this, they look at this and say, well, this is really not a significant amount, 10%, that's still pretty low. But when you're looking at these probabilities, while they may seem low, they're basically telling you in that hatched area where you see 10% that you could see severe weather within 25 miles of any point. So if you take and put your cursor there and you pick a point, you will likely see a 10% increased risk of seeing a tornado, in this case, within that 25-mile range. And so you're looking at, the 25 miles comes from just basically looking at kind of a major metropolitan area. So we know that, severe storms tend to get a lot of media coverage. And so when you hear about severe weather, it's generally broadcast pretty well over the TVs and other outlets. But in the end, what you're typically hearing is a lot of severe weather happens a lot of the times. And that's not really reality. If you think about your own backyard, on any given day, the chances of a tornado going through your backyard are pretty minimal overall. And so when you have a 10% increase, I mean, you're talking about a huge threat, much greater than usual in that area. So that's why they tend to kind of look at this and downplay it, when actually this is a really significant amount of increase on any particular kind of random day. Now if we look at the overall surface analysis of this is at 0Z, so this is actually as this weather system is getting started. We see an area of low pressure kind of in the north central part of Missouri, and the main upper level trough is actually well behind this at this point in time. And it's easy to think that, well, that trough is way out there, there's not a lot of upper level support, but this is what we have, it's called differential heating that's going on in the atmosphere. And essentially there's a tilt, a vertical tilt if you will, back into the colder air, where you see the upper level system versus the surface-based system. That tilt actually gives it the energy. We call it baroclinic instability, and that's actually gives it the energy it needs. And the fact that this is, you can see multiple concentric isobars around it, and you also throw in a dry line, of course, into that as well, which is, again, really a bit unusual for this time of year to see that dry line, but it is actually there. So really, you can see that the dry line is actually more of a dew point front, and the green numbers here are all the dew points, and you can see a significant drop in the dew point across the front there. You see the numbers are in the 30s and low 40s here, but you see in the 50s and 60s on the other side of that. So definitely there's a dry line going on in that area. And then we see our frontal system, and some of the temperature drops here are pretty significant. We see 70 degrees and then 40 on the other side of that. That's a pretty significant drop in temperature. And even the 30s back, or upper 20s, even further back into the colder air. We also see that there's plenty of moisture here. We've got dew points up near 70, which is really pretty darn high in many locations, or even in the mid or upper 60s in many locations. And you can see the winds all from the southerly flow. And where we get severe weather is when we have winds from the southerly flow, and then we have the upper level winds that kind of go in a more, if you go backwards in a clockwise direction, you see now the winds are all in the more northwesterly, a cold, and you can see that aloft as well. And as a result of that, we get a pretty good temperature differential, and we have a lot of moisture, a lot of that fuel for convection to occur, all ahead of that frontal system, which helps produce some of that lift. And again, there's a lot going on here I'm not going to be able to go through, but this is kind of the setup here. And as time went on, this weather system continued to kind of churn up to the north and east with time, and eventually that frontal system made its way closer to the areas where we saw most of the significant severe weather, those tornadoes, providing that region with a lot of lift as that upper level system kind of comes in behind it to sweep over top of it. So this is the kind of the setup that we're looking at, is that the daytime heating, there was a lot of breaks in the clouds here, so there's a lot of good daytime heating here, kind of set the stage for some really warm, moist air near the surface. And as that stage gets set, what happens is that as the evening, as the sun sets, that setup kind of stays in place, and we get the upper level system to come in behind this and help bring in that colder air aloft. And sometimes this kind of setup, we can shift this thing by 4 or 5 hours either direction. It may not have happened, meaning that setup may have been significant enough to produce some convection, but the way things happen here, sometimes it's just a matter of literally an hour or two, and that's where I think some of the model forecasts that were being looked at in this were telling maybe a slightly different story, and that setup sometimes is very much teeter-tottering on being a very major weather event, or one that's pretty significant, but not necessarily what we saw here. And so I think the setup and timing of this was very crucial to creating the significant event it was. And let's go ahead and again take a look at some of the upper level depiction here, and hopefully that we'll get a better feeling. So let me pull this up. So if we look at the GFS model, and specifically I'm going to pull up the 500 millibar chart for initially here so we can see what's happening. Now this is the analysis that's valid in this case at 0Z, so it kind of is the same time frame of the surface analysis we kind of just looked at. So if you look at the surface analysis chart here and look at the where the surface low is, it's basically kind of ahead of that trough. So it's not, we're not in a situation where it's right over top of the trough. That surface low is here in the northern part of Missouri, and and essentially kind of ahead of that trough. And here's the cold air kind of coming from behind it. So what's happening is we're laying down a lot of that warm, moist air near the surface, and we're going to bring in a lot of cold air aloft. And we know when we have warm air at the surface and colder air aloft, and the winds shift around in direction, we get what essentially is shear in the atmosphere. That will produce essentially the severe weather we're seeing. And we watch this trough kind of move through and eventually become, kind of very, very sharp trough, kind of a situation where we've got this vorticity occurring in that area, really kind of gives that that trough a lot of strength. So it's in a strengthening state here as it's moving through, and we're getting that severe weather to occur. Again, this colder air is kind of pushing in, and as that weather system at the surface, we saw that frontal system helps to kind of get things going with that upper level system, still pretty far back in this region. This is at 9Z when some of those storms were still moving through Kentucky into Tennessee and such. The other aspect of this is looking up even higher in the atmosphere. And we can certainly do that at, let's say, 250 or 300 millibars. And so if I bring up the 300 millibar chart, one of the things that, if you've done any training with me, one of the things you have learned about is this concept of what essentially is a jet streak, and that's a faster flowing air. And this is at essentially 300 millibars, or roughly 30,000 feet up. And what we see is this jet streak appearing right here. Again, this is at 6Z, when kind of things are starting to really start to take shape in this area. This upper level feature here allows for, again, more significant upward motion. This divergence aloft, as this faster flowing air over slower flowing air allows upward pressure and allows that essentially that area to blossom up. Again, the same thing as I said earlier is that the surface system kind of sets itself up, and this upper level system comes in behind it, and you can see it's in a process of strengthening as that jet streak here even gets up to 150 knots. So we're in that scenario where we're starting to really build this weather system, and that's very common as these weather systems come out of the Rocky Mountains. And that's, kind of creates that really large jet streak through the time frame and produces some of that severe weather. So this is kind of the setup that we see here, and it gives you a really good indication of the fact that when we look at most of the weather, we look at the surface charts, the surface analysis or prong charts. Seeing what's happening at the upper levels and seeing the progression of this really gives us a much better feeling for how this can all kind of work together and play out. Now, one of the other aspects of this, I did not get into all the different charts that we could see. Certainly won't be able to spend much time going through all those, but this other one I like to look at too from time to time is the HREF, which is available on Easy Weather Brief, and this is essentially the ecotops. This is from the High Resolution Ensemble Forecast, and this is the ecotops forecast. So it basically says, what are the probabilities that the ecotops will be above 30,000 feet in this case? And so you can see here as this weather system starts to take shape at 3Z, and the overnight hours, we start to see these ecotop heights are definitely going to be above 30,000 feet up here further north, and that eventually starts to set up that line and the more significant convection. But again, this doesn't look all that horrible. In this time of year, we don't get the tropopause is not as high, so some of these storms don't quite get up there. But some of the weather watches were showing that the possible maximum tops could be up to 50,000 feet in some of these areas. But for sure, that by the time we get to, let's say, 6 and 7Z, this weather certainly is likely to be pretty significant overall in that region. Because of those taller cloud tops, we know that this is deep moist convection. The other thing that we kind of want to look at too, and get a kind of a better understanding of, is the overall simulate reflectivity forecast as well, which kind of relates to this. I want to also go in and do a quick discussion, look at the Storm Prediction Center's discussion so you can see some of the concerns they had. But this is going to be the simulated reflectivity. Let me see if I can pull this out here. So this is the simulated reflectivity forecast for that day. And once again, you can see this is about at 3Z. And anywhere you see these areas here where you see kind of the darker, black colors here, that's basically looking at updraft helicity, which is a kind of a rotational aspect of things, and that's where you'd expect the possibility of tornadic thunderstorms in that area. And there was certainly, this is one of them that was probably associated with that long track storm here. Maybe not in the exact location, but you can see kind of it originates right around just in northwest or northeast part of Arkansas, kind of right out of that cell, right around 2Z, and watch that kind of move up. And that's that one long track kind of storm that went all the way up into probably near Cincinnati, according to this, but that's probably not quite in the exact area. But that, if you were looking at this is what you would say. You would say this would be a long-tracked supercell thunderstorm that produced that one of that more significant tornado that some estimates were 125 to maybe even 200 miles on the ground. Certainly you can see that here pretty clearly. Again, I think it should have been shifted a little bit further south of where it actually occurred. Nevertheless, it's again a good information for forecasters to know that, by the way, this is going to be a pretty significant event. And there were lots of smaller tornadoes all through this area, and I wouldn't be surprised if they don't classify this one as EF4, maybe even EF5 in that area, although I haven't taken a look at the analysis that the National Weather Service does after this. But that's, again, a good example of where you'd probably expect to see the most severe weather. And there were other areas, too, where there were possibility of some of this updraft helicity that was going on there. But I want to take a look at some of the discussions that were wrapped around this, and specifically, let me see if I can pull this over. The discussion, with every convective outlook, there's a discussion that comes along with it, and this is the forecaster that's kind of looking at the situation. And I won't go into and read through all this, but there's a number of places here I think are kind of interesting to read through. There's a southwesterly low-level jet. That's essentially that air that's kind of flowing at a low level from the south and west, bringing some of that warmer, moister air in. Expected to increase meaning we're dealing with increasing or intensifying across the eastern Texas, lower Mississippi early in the period. And again, this goes from 12Z to 12Z. This southerly branch of the low-level jet will encourage higher quality boundary layer near the surface air mass to advance north. Higher quality meaning moist and warm advance to north into the middle Mississippi Valley ahead of surging cold front. So this is before even the first cumulus cloud developed here. Early morning, lower 70s surface dew points are noted. We saw that as far north as PSN to IER over eastern Texas, Louisiana, with lower 60s dew points into central Arkansas. There is a little reason to doubt moisture will advance into Missouri and Illinois ahead of the front, as capping will prevent applicable convection until mostly after sunset. So there was definitely some capping in the atmosphere, and capping is sort of like shaking up a bottle of soda and then letting go of pulling the cork, so to speak, and having it kind of explode. That's what happens in the atmosphere, and it's certainly after sunset. It's laying that ground, that high quality boundary layer air that we talked about. Latest model guidance suggests moisture advection cooling profiles aloft will result in destabilization ahead of the surface low, and that surface-based parcels should become buoyant by about 2 to 3Z. Normally we think, surface parcels are buoyant in the afternoon time frame, but in this case that's not really true because of that capping that was occurring. But here's the thing, there is great disparity among the latest high-resolution ensemble forecasts regarding the timing and spatial distribution of convection during the initiation phase after sunset. So they're trying to grapple with what is happening here, what is causing this, and what kinds of things do we need to be concerned about, and timing is really all part of this. And I think this is really what the real issue here is, being able to understand how this is all coming about. And this is the forecaster kind of throwing their hands up and going, this is really going to be tough. And I really feel for those folks because this is a tough situation. They don't want to overwarn and they don't want to underwarn, and in this case they're trying to give it their best shot. But it says based on forecast soundings have opted to increase severe probabilities. That's a good thing. Further west across the warm sector ahead of the surface front in Missouri. Latest thinking is scattered supercells could develop by 3Z, then track northeast within a very strong sheared environment. That shear is what gives those the chance of becoming tornadic. With thunderstorms not expected to develop until after dark, diurnal heating will not contribute appreciably to buoyancy across this region, although it created a setup early on. And in many cases, that setup was essentially again, the precursor for providing all the ingredients, again, that high quality boundary layer. So ultimately, even so, parameter space appears to be favorable for supercells, and with dew points expected to rise into the lower 60s, a few strong, longer-lived tornadoes seem plausible. And they hit that right on the money there. And so convection should be strongly forced across northern portions of the outlook where intense 500 millibar flow and strong height falls. Height falls meaning that trough is moving in, that colder air aloft is moving in. While wind profiles will support supercells, through sunrise there will be a propensity to evolve into a squall line with more eastward movement. Tornadoes and wind are the primary severe threats, though some hail may be noted with early evening supercells over Missouri and Arkansas. So in the end, that's really what the forecasters here were trying to work through. And these are the experts. These are the folks that spend a lot of time and get really highly trained in this area. And again, I really understand their and I feel their pain in this particular situation. So we could go on, and I know I've reached a pretty long amount of time for this so far, and there certainly are other different aspects to this in terms of looking at even the prog charts. The prog charts here were not all that illuminating with respect to what might be happening, but certainly we can look at the prog charts to kind of get a sense for what's happening there, and this is valid at 0Z, not really showing much in the way of severe weather. It's not until we get to the 6Z that we're showing the possibility of the severe area here, but it's certainly not something that you want to try to even approach with respect to flying. And of course it's happened all in mainly the overnight hours, which again adds to the element that most people were either sleeping or not very well prepared to do that. So again, this is just gives you a kind of a very, very high-level overview of the things that went on with this particular scenario and why it was, kind of as strong as it was, and maybe not as well forecast. Maybe surprised a few folks, but that's the nature of weather and meteorology. So that wraps up episode 28 of Easy Weather Chat. My name is Dr. Scott Denstead, and as always, I hope you enjoy the simplicity of Easy Weather Brief.